Okay, I've never done this before, but we are going to record our lecture here on my desktop as if we're in the classroom. So if you'll bear with me, it might be weird. I don't know. We'll find out. So this is going to be atomic structure unit, subunit ions. This is the first subunit. This is the last subunit before your quiz, next block that I see you. So make sure you pay attention, if you would. Okay, so first off, the things we're going to learn in this lecture or lesson, you need to be able to describe how cations are made and how anions are made. These are both vocabulary words that you'll be familiar with by the end of this lesson. And you'll need to be able to show the appropriate abbreviations for ions with mass, atomic numbers, and the charge. That's just those numbers. If you've looked forward in your homework, there's numbers on the top, bottom, left, and the right of your symbol of the element. So we're going to go through and just quickly learn what cations and anions are and how to do our little numbers on the sides of our symbols so we can appropriately abbreviate ions. Okay, so first, an ion is just an atom that has a positive or negative charge. We've discussed this in the warm-up on the first day of atomic structure, so this shouldn't be a surprise. Ions form when atoms gain or loses electrons. So basically, that's kind of a big deal. So whenever an atom loses or gains an electron, this is basically the whole concept of chemical reactions and bonding and all the cool stuff you guys get to see in the lab. This is what's happening, are these elements or atoms are just giving and taking each other's electrons. And that's what an ion is when they have given or taken someone's electron. Now, how to write ions. It's basically just the symbol, and then at the top right, you're going to add a plus or minus sign, followed by that number. And the number that it's followed by is just the number of electrons that it's gained or lost. So it represents the amount of electrons gained or lost. And it's actually kind of opposite of what you would think. So if it's a +3, for example, it actually lost 3 electrons. Or if it's a -2, it actually loses 2 electrons. So keep that in mind. Okay, cations. So cations are just like positive ions. If you'll look, I don't know if you can see what is this, an arrow, the pointer. This is a cation. They're typically smaller than the negative ions, and they have a positive charge. So a cation is just a group or just one atom with a positive charge. That's it. Just a cation is a positive charge. There's a Greek word that if we were all together, you guys would tell me, like my students did last year, that represents like above. No, it's below, something like that. Anyways, if you're Greek and you speak Greek, this kind of makes sense. Cations means that it lost electrons. So maybe the cation or cation, I don't know. It means to be below. I don't know. You guys will tell me whenever we see each other again. But basically, cation, just keep in mind that it is just a positively charged ion. That's really all you need to know for this quiz for sure. Okay, and the cation, as far as naming, we're going to get into naming a little bit later, but just keep in mind cations have the same name as the element, but just you just say ion at the end. So for example, lithium, I know you guys like lithium. So lithium on the left side of the periodic table, it has a plus charge. All of those on the left side have a positive charge. So you would just say the lithium ion. That's how you would call it. Okay, so sodium and calcium, they're both cations, but they have different chemical properties. So for example, this guy right here, it has a +1 charge. It's going to be looking for another ion on the right side of the periodic table that has a -1 charge. This one has a +2 charge. It's going to act chemically different than the sodium ion. Okay, Um, Anions, just basically, it's the ion with the negative charge. It's the one on the left, okay? So anions are typically larger than the cations, but the main thing you need to know as far as today and kind of in your introduction to ions, we're not doing bonding in this. We're not doing bonding in this unit. We will later when we're doing chemical reactions, but all you need to know is that anion is a negatively charged ion. They are all of those guys on the right. The cations, this one, it's all of the elements on the periodic table on the left, and anions are on the right. I guess I should have switched these two, huh? Okay, so the name of the anion, you just end it with "ide." So like oxygen and chlorine, they're on the right side of the periodic table, which means they are anions. They are negatively charged. So you would just say, like, for example, if you wanted to name the oxygen ion, it wouldn't be called oxygen ion, like I had mentioned earlier with lithium. If it's a cation, you just say lithium ion. But if it's oxygen, if it's on the right side of the periodic table, you would just name it, like, take off the ending, and it would be called oxide or chloride. So you just add that "ide" on the end. Like that. Okay, so this pertains to all of the elements on the right side of the periodic table. I mean, not the noble gases, but all of the other ones on the right side. Okay, this is a big part of your quiz. This is about half of your quiz. Abbreviations. So basically, we know that this is the symbol, right? And we know that that number at the top represents the number of protons. And this, I'm sorry, it might be different now because we're doing ions. Yeah. Okay. So, sorry, moving on. So this would be the mass number, and then this is atomic number. Keep in mind, this is only whenever you are doing ions. Okay, we're writing the abbreviations for ions. Don't get this confused with that stuff that I taught you the day prior, where we had like the atomic number up here and the mass number here. This is a little different, and you'll see how this isn't. Don't picture this as a square on the periodic table. Picture this as this kind of being right here and this one here. You'll see some examples in a minute, but don't think of these as a square on the periodic table. Think of these as just where you put the numbers, because here on the next slide, you're going to see a bunch of symbols with like numbers here, here, and here, and you're going to say, what is going on? But I'm telling you now, up here at the top right is just the charge. Up here at the top left is the mass number. We learned how to do mass numbers the other day. If not, you need to check out your second lesson of this subunit. And then here's just the atomic number, and we all know that that's the where to find that. That's on the top of the periodic table squares. Okay. Okay, so if you'll see here in a second. So what we're going to do is we're going to look at these, and you're basically giving, this is what your quiz will sort of look like, and you're going to be given random things through here, and then you'll be asked to fill in these blanks, or maybe fill in the symbol, and you'll need to fill in 3 numbers. So here it has the mass number, but it doesn't have the atomic number, or the number of protons. And here it doesn't have the charge. So I also have family, so you're going to hear them. So basically it's going to say we have sulfur, right? And we know sulfur is the element we're talking about because it has the S here. And the number of neutrons, we have it at 16. So if you'll look at the periodic table, maybe I can pull it down. There they are. Okay, so basically, like I said, all of these guys have a positive charge and the transition metals, and then these all will have a negative charge over here. And then these are neutral, obviously. So we don't deal with these with ions because they don't become ions. So the question, current slide. Okay, so it says sulfur, and then it gives us the atomic number 16, and it says number of neutrons are 16. So basically, if we have atomic number and we have number of neutrons, we could add these two together and get the number of protons. So we would have the number of protons here, and then we would put 32 here. And then the atomic number would be the number of protons, so that's protons. So the atomic number would be 16. Why don't I have this? This should be mass number, sorry. It should be atomic mass number. Anyways, so that would be the 32, number of protons 16, and then number of electrons, that's going to be a little different. If you'll notice that it has 2 extra electrons because it's a -2 charge. So if it's a -2 charge, that means it's not neutral. So instead of having 16 electrons to match these protons, it actually has gained 2 electrons. So it's gained 2 negative charges. So it should be a N18 charge, or I'm sorry, 18 electrons. So I want you guys to kind of do this on your own. You'll probably need a periodic table. You may have to Google it, but make sure you're able to do this. So keep in mind, this would be the atomic mass. So let's go back and see what we didn't see. So for example, let's say we have atomic number of 7 and then number of electrons of 10. So how I would figure that out if I only had atomic number 7 and number of electrons to go by, I would look at my periodic table, okay? I would find atomic number 7, which is here. So we have nitrogen. So we know it's atomic number 7. And then what else does it say? And number of electrons 10. So if it's atomic number 7, we already know that we have 7 protons, right? So atomic number 7, 7 protons. The mass number is 14. And then to find number of neutrons, you would take the mass number minus number of protons, and that would equal 7 as well. So we'd have 7 neutrons. And then as far as the charge goes, I can tell you a little trick as far as determining the charge of these elements, because you're probably thinking, how do I know that oxygen is a -2 charge? How do I know that chlorine was a -1 charge? Or chloride, if we're talking about the ion. So basically these guys all in the noble gas row, these guys have a neutral charge. They are not charged at all. These here, the halogens, or group 17, sorry, these have a -1 charge, and there's a pattern. These have a -2 charge. These have a -3 charge. Okay, we're going to skip this one for now. This tends to be a little confusing, but basically it can act as a plus or minus charge depending on what it's bonding with. All right, and then these guys, these have a +1 charge. These have a +2 charge. We're going to skip these as well. These are a little bit weird and don't follow any nice little patterns. They're kind of random. Actually, they're not random, but we determine the charge on these when we go over electron configuration. So we're going to skip these, and then this would be a +3 charge. So a quick overview. This group, the first group, is a +1 charge. Second group is a +2 charge. We jump over here to the third or 13th group. That's a +3 charge. These are a little weird. It's a plus or -4, could go either way. We'll talk about that in bonding. This is a -3 charge, -2 charge, -1 charge, neutral, okay? So those are the charges, and you can just use that. So we were talking about nitrogen, so it's a -1, -2, -3 charge. So we'll go over here. Okay. So if we have nitrogen, we knew the symbol was N. We knew the atomic number, the atomic number is 7, and the mass number was 14. And the charge, we could put -3 already. We already know that. But if you didn't or you forgot, with the number of electrons. So the number of electrons should equal the number of protons, right? If it was a neutral atom, but it's not. It's a -3 charge. So you would take 7 electrons, add those 3 minus charges, so 3 electrons, and that is why it's 10 here. Okay, so here are the answers to the other two. I'm not going to bore you with my explanations for the last two, but we will go over this in a warm-up prior to the quiz when you get back. So make sure you are able to fill out a quiz of this type whenever, a table of this type whenever given a quiz. And let me show you some vocabulary words I would recommend studying. These right here. Study those. And then I would recommend being able to fill out a table that looks like this. And yes, these are literally pieces from the quiz, so hopefully you're watching. But these I would recommend being able to fill these out. So atomic number, and I'll just kind of had it just like I just showed you, a couple of examples. I'll have the numbers scattered out and some element symbols, some of them you're going to have to just tell me. So be able to do that, and we'll do a practice warm-up on that one. So yeah, I hope you have a good evening.